Please pause the video and take a moment to read this important safety message. Hey, welcome back everybody. I decided after all just to make this a two-part series. Part one was kind of building the chassis and putting everything together. Part two then is the actual building of the tube socket board. And I was going to make a third part on the software, but I've decided just to integrate the software part here into part two. Just basically do this up through the making sure everything is working. At that point, then I think I turn it over to Chris, and he's made a lot of good videos on how to use his software. So this video series is more about how to build the tube tester itself. Okay, here on page 11 of the chassis documentation, it basically starts here by saying you got to wire the top plate B1. Requires a little effort, they're warning you. First step is mounting all the tube sockets, and the following figure shows you how they're assigned. So here's the tube sockets, number 1 a U4A, 2 a KA8, K8A, so on and so forth. It shows you where the 10 tube sockets go. Then it kind of gives you a description of each one of them. And then it will warn you down here, please note that O5A and PA8 are different. In other words, let's see if we can find those. Let's see, yeah, this one here is different. Nope, I'm sorry. This one is different. The pin sockets go 1, 2, 3, 4, 5 instead of going clockwise. And this one here, instead of going clockwise, 1, 2, 3, 4, 5, 6, 7, 8, goes the opposite direction, 1, 2, 3, 4, 5, 6, 7, 8. So you have to pay attention to that when you're wiring these up. What you'll ultimately end up doing is connecting all the pin 1s together and then back to a socket that's labeled, pin 1. And then it also warns you here that when you get to the 9-pin socket, there may be a little gap in between, and you may need to fill this with some washers right here. If you'll remember, they do not supply the nuts that you need to lock down the tube sockets. Those are something you'll have to provide, and you can go to your local hardware store and get those. So let's get over on the bench and do this. Okay, now we've got this plate, and if you're wondering what the first step is, yes, we need to put in 1 through 10, all of these, and mount them up just like we did the others. Okay, we've got all the blues mounted in here, and I've turned all the blades this direction. And there again, Mike Galusha is the guy that made this and sent it to me. I can't say thank you enough. These things are a pain to put on. And like I said, I think Chris is now, I saw a post where he's including a tool made to put these on with. But all right, onward to the tube sockets. Okay, I'm going to use these just because I have them black oxide. They're number 4 screws, 40 thread times 3/8 inch length. And I've also got the number 44 K-locks, but you could get same size screw and whatever at your local hardware store. Okay, there you go. As much as I would like to say this was a 5-minute job, it's more like a probably 30-minute job to mount all these tube sockets in here properly. This one here, which is right here, large 9-pin, you do have to put some spacers in between on both sides. As you can see, I've got thick washers right here, and it tells you that in the instructions as well. So now that we've got this put together, it's as simple as this is pin number 1 right here. And then what you do is you're basically going to run a wire to pin number 1 of every single tube in this socket and kind of series them all together. And then along the way, you're going to insert a ferrite bead between each wire as you make these connections all along the way. And I'm not exactly sure how long that'll take me, but I'm going to get started. And Chris provided a good bit of white Teflon wire here, so I think I will use it and instead of going into my own stash. Okay, up next I went over, once I got everything mounted, I went over to back to the instructions for the chassis. And I basically went through each of these pin diagrams and I labeled them here on the actual sheet. First off, I labeled these 1 through 10 from the back side to correspond with this, so I don't have to keep flipping it over. And then, like, this is a normal 9-pin socket. I labeled 1 and 9, 1 and 9. This one I just labeled 1. It's an octal 1 through 8. I know that one quite well. Some of these get a little odd though, like the 4-pin. It's 1, 2, 3, 4, and these 1 and 4 are the large pins, here, and I put a mark between the large pins always. Oops. 1 and 4 here are the large pins, and I always put a mark between them on the tube socket. 1, 2, 3, 4. This is like an 807 socket here. You kind of go 1, 2, 3, 4, 5. This one I labeled 1 through 8. It's a lock tool. This one's a little odd. It goes 1, 2, 3, 4, 5 over here. And then some of these are the backwards ones where it goes 1 through 8 around this way and 1 through 10 around this way. But I just either labeled the pin socket or the metal chassis near it, just to make things much easier as I'm doing this, and I don't have to keep flipping over or flipping back and referencing to a chart over there. Okay, up next, what Chris says here is you need to wire all the pin number 1s together serially. And you should connect them to banana jack number 1, which we talked about. What it does say is, please mount a hollow ferrite bead to the wire every 2 or 3 wires to prevent high frequency oscillation. The same rule applies to pin number 2, 3, etc. Please note that the ferrite beads are conductive, and it is advisable to glue the beads to the wires to prevent short circuit. The following figure shows the results of connecting all pin 1. So if you scroll up to page 15, you can kind of see here pin 1 comes down, goes over a ferrite bead to pin number 1 of this, pin number 1, 1, 1 around, and you'll notice every 2 or so wires he's connecting a ferrite bead. And then coming along here, you can better see the ferrite beads glued after you get done wiring them all up. Looks a little bit like a rat's nest, but it's just the way it's going to turn out. I hate to say that. And you can see where somebody's used like a hot glue gun or something. I'm probably going to use just a little bit of super glue or silicone glue or something along the way to keep these in place. But you get the idea here of how it's going to look when you finish. And I actually, since I have a lot of Teflon wire, I may wire each of mine a separate color, 1 through 10, just so that if I ever had to do a replacement down the road, it'd be really easy to figure out which wires go to what if I ever had to replace a tube socket if it wore out. I also thought about using some higher end like Belton or something tube sockets in this, but the octal wouldn't have fit. I would have had to drill out a slightly larger hole, and I just thought, I'm going to build it the way it is, and if they wear out down the road, then I'll worry about replacing them. But we're going to get over here and get to wiring. Okay, another tip, what I'll do is I'll take the wire on the spool here, and what I'll kind of do is lay it to where it needs to go, and I'll kind of fabricate the bend with my hand here like this, and I'll kind of figure out, okay, that's where I want this wire to run. And then what I'll do is I'll come along and I'll snip it off right here. And then once I've got my wire snipped, what I'll do is I'll go ahead and put in one end of it into the socket that already has a wire in it. And then oftentimes what I'll do is I will go ahead, let me get this in here where I want it. I'll go ahead once I get it in here, and I'll go ahead and solder both wires in place then. That way, now all I've got to do is kind of route it the way I want it down to the other end, then I can tuck it in. It just makes, because a lot of times you're trying to tuck this in while that end's popping out and whatnot, but you'll figure out what I'm talking about. And as you can see now, we've got 2 whole sets wired up here. I did the first set in orange, the second set in purple. Like I said, that's not required. It just makes it a little easier for if you had to replace a socket later. I think it would make it a little easier, but nonetheless, onward. Okay, one thing to note, when I got up around, I'm going just working down 1, 2, 3, 4, 5, 6, 7, 8. When I got up around number 9 and 10 here, I'm going to switch my wiring pattern. Instead of pulling all the way over here to this tube socket and then coming all the way back over here, I'm going to find the shortest path between, because once you get to 9, there's only, I think, 3 tube sockets in all of this that need wiring up. So find the shortest path possible as you do that. Okay, she's all wired up at this point. I will tell you, beginning to end here, about 3 to 3.5 hours worth of soldering. I know it looks simple. It's a lot of tedious cutting, tucking, bending, recutting. You know, it just it's time consuming. It took me about 3 hours, and I would consider myself a very proficient solderer. So just it's time consuming is the bottom line. So just prepare for the journey and take it slow and do it right, and it will turn out quite well for you. What I have not done is glued these ferrite beads in the center of each of these wires, and I've been debating on how to do that. I thought about some you know, super gel and super glue, and then I was thinking I might just mix up some epoxy and use a screwdriver to dip a little bit on each one. So I think that's what I'm going to do. Okay, what I'm going to use is this 5-minute epoxy from Bob Smith Industries. It's about $13 for a pair of these. You can get them at Hobby Lobby, or you can order them off Amazon. And I usually just cut an old box lid, and then I've got a screwdriver that I use for nothing but epoxy to stir it with and then apply it. I don't know that this is the best route. You could use a hot glue gun, but I've tried hot glue guns in places like this, and you just end up with these strings everywhere. And the smell, I started to do this, and the smell of it about killed me. So I think I'm going to go down the epoxy route. There's probably other paths you could take. Okay, the way the epoxy works, you make 2 equal sized blobs, one from each bottle, and then you stir it up, and once you stir it up, it activates the epoxy resin to start curing, and from that point you've got about 5 minutes to do what you want to do here, because this stuff will turn hard as a brick. So I was just going to stir it up and get just a little bitty dab on into my screwdriver here, and then find a spot here, and I'm just going to dab here like that on one corner of a ferrite bead, and I'm just going to pull them all to the middle, and dab a little on the wire and a little there. It won't take but a tad, I'll tell you that much. Any rate, I don't think doing this on camera is my best move, so I'm going to drop the camera and finish this. Okay, we've got them all done, and I did learn a valuable lesson. If you're using epoxy, don't make such a big pile to begin with. Kind of cut that in half, because I ended up having to make another one. What happened was, as I got into this, it took me more than 5 minutes to do them all, and my glue got very stringy along the way, and then it actually got hard, so I had to make another pile here. So at any rate, all done. Keep in mind, your goal here with the glue is, one, I was trying to keep them in the middle of the wires, but two, more importantly than that, make sure that you're suspending them in places that they can't drop down and short across two pins somewhere and cause a short, because these are conductive as mentioned. Okay, slight little bit conflicting info between the two manuals, but they're close enough. What it basically tells you is SRV1 right here, which is this little variable resistor on the power supply. It says to rotate this clockwise all the way to get the highest output voltage, about 28.5 volts DC. But then if you go over here to the actual motherboard instructions, it says it requires a 29 volt power supply basically. And it says the default output voltage on this power supply is 27 volts. The output voltage can be increased to about 29 volts by turning SRV1. So we're going to turn it up to about 29 volts. Okay, and they were right when they said that the default was about 27.5 or 27 volts or so. So I'm going to turn this little potentiometer till we get to 29 volts. We're going to leave it. That's as far as it'll go, 28.98. Alright, we're going to leave it right there. Okay, the last step is going to be putting this plate back on. Just make sure that you don't end up pinching any wires in between the chassis lip and edge here. That was a bad problem with the old TV7s. The chassis used to close down on the wires a lot. People would tighten them down, and then over the years they would the chassis would wear the wire thin, and then short out windings, and ultimately burn up some of the good transformer. So anyway, we're going to drop in the 6 screws here and call it a wraps. Okay, we've got the top plate mounted in now, and while I've still got the front panel off from adjusting the variable resistor on the power supply, I'm just going to look down in here real good and make sure that none of my ferrite beads from the top plate are touching anything else, or none of my wires are getting close to the fan, things of that nature, just to make sure we got good clearance all the way around. And I'm actually pretty happy with how this whole thing turned out. Now we're in a place we can just drop the front cover back on, and we will call this complete. Okay, let's dive into the software now, and I'm going to show you how to install it, get the tube tester up and running, and how to actually test a tube. What I'm not going to do in this video series is go in depth on how to use the software. Chris, the owner of eTracer, has made a lot of videos on that, and anything I would do would be kind of duplicative to that. So I would highly recommend, if you're going to get one of these tube testers, or you're considering getting one, go find this tube tester, go find this Facebook group, Vacuum Tube Curve Tracer Project Discussion in English. I think he has another one in Chinese. So anyway, you find his site here, and you can see, you know, Chris posts out here, here's a new version of the software, and here's exactly what it fixed. And you see people posting, you know, kind of their builds and things they're doing all along the way. He talks about, you know, how to do different types of tests and whatnot. So it's a really good forum that's pretty active. But if you click on the About page over here on the left, it'll take you to basically a link here. You can get to their website, and I'm going to go to the Downloads page here. And from there, I'm going to go down here to the eTracer Documents and Software. And we were here earlier. This is where we got our user manual for the chassis and for the eTracer. There's a couple other things we're going to want to download at this point in time. Okay, first we're going to want to get this eTracer software version 2 for the actual unit. And you'll have to log in if you're not logged in to be able to download things. So you may have to create an account here. And you can't see it at the bottom, but I've got this file downloading now. And I'm going to go back. I'm also going to download the software user manual for this. And it will just pop up here as a, whoops, download. It pops up as a new tab here, and I spent a couple hours last night really reading through this document, and it is a well-written, detailed document. I find it much, much better than the hardware installation manual, where you're kind of flopping back and forth between two different documents. Does a really good job of explaining how this unit works. Then it kind of goes into just, you know, things about how the software was written, the device drivers and system configuration files you'll need. One thing it will tell you here is that eTracer relies on something called VCP, Virtual COM Port Driver from FTDI. Normally this comes installed on all Windows machines, Windows 7, Windows 10, whatnot. But it does say here that, you know, it could have been something that somebody uninstalled at some point in time. So if you need the drivers, they're right here. Then he kind of does a walkthrough and orientation of the graphical interface, and we'll go through that. And he walks through what each little zone and section does, where you would provide input, or where it would be providing you input. Then it walks you through how you would do a calibration of this unit. Now, let me show you this real quick. Okay, this is a file that Chris sent me, and it's matched to my serial number. In other words, he provided a calibration file from the factory, kind of. You can see I got this back on September 16th, so it's been a while. It says calibration file for the eTracer your order is attached. Please rename it to eTracer.cfg and put it in the same folder as the executable. So I'll tell you what I'm going to do. I'm going to go ahead and download this file, and it'll warn you, do you want to keep this? It could be harmful, and I'm saying yes, let's keep this. Okay, so I've now downloaded the configuration file as well. Okay, back on page 7 of the software manual, it will tell you it's a Windows only software. So if you're wondering whether this runs on a Mac, it does not. It says it's in 32-bit mode and it can run in under 32-bit or 60-bit version, 64-bit version of Windows. It's supported on Windows 7, 8, and Windows 10. It says Linux users can execute the eTracer software under Wine, which is an emulation software. And he says basically Wine is the only one with Ubuntu Linux that has been verified to work. So you're kind of getting out on a limb on your own there if you go down that path. But some people have verified it working. And basically what he then says to do is create a folder and name it whatever you want to, and then unzip the download file that you had downloaded. So let's do that together. Okay, this is just File Explorer, and what I've done is I've got a data drive called C. I keep all my working files and save files and installed software and whatnot on a separate drive than my operating system, and then I back up this separate drive, so if I ever lose it, my operating system, I'm not hosed, and I can simply reinstall the operating system. That's just a little tangent, but I've got this disk called primary data disk. By the way, I have a backup data disk, a second drive I copy everything to on a nightly basis, and then it gets copied up to the cloud. Just a few PC tips there. All right, so primary data disk, I made a folder. I called it eTracer, and I put a capital T in there for whatever reason. And then it just says, hey, we're going to extract these files here. So I use a program here called WinRAR is what I use. And once you've unzipped it, you can actually then get rid of the zip file to save you the 131 meg of space. And you've got some release notes here that basically tells you what all he's done since he's been on version 2. There was a version prior to version 2. And then if you'll notice here, you've got the actual executable, and this is where you would put your tube configuration files. So a couple things on the tube configuration file. Okay, in this folder, if you click on it, you will see all the tube types that have been tested thus far and that you could use within this tube tester. There's quite a few here, but not an unlimited amount. It's mainly audio tubes that people are wanting to run curve traces on. For matching, but what the great thing is, the user manual here tells you how to use something like the RCA receiving manual to go in and actually input your own variables out of the RCA manual and create a new tube type to test with. In other words, you're not limited to what this comes with. You can input your own tubes, and then you can save those off. And then there's a place on Chris's website where you can upload user-submitted vacuum tubes. And I'm not sure exactly the process. Maybe I'll ask Chris whether he just leaves them there in the user-submitted, or maybe he then looks over them and adds them to his list. I'm not sure, but the list has been continuing to grow along the way. Okay, before I start this unit up for the first time, if you'll notice, this is the file I downloaded. Chris had emailed me, and it says to rename that eTracer.cfg. Okay, we're going to double click the eTracer executable at this point, and it is a 132 meg file. I will tell you, the first time you run it, it takes a good 45 to 50 seconds for the application to actually open up. Okay, after you ran it one time, it seems to open much faster going forward. And whoa, and there you go. We've got the application up and running now. Let me bring this in and maybe shrink this down. Okay, so at this point, okay, what you're going to want to do is load your tube configuration. So you'll click Load Tube Configuration. It takes you to this file, to the directory eTracer tube config. You'll go to 12AX7 here. And what it does is it populates all the test fields over here with the values it's going to test for. It also fills in for you the tube configuration over here. And let me pull up a picture of the tube tester and how I wire it out to help explain this. Okay, I just superimposed a picture on top of this of what I've got, how I actually wired it up over here. And you can see I've got pin 1, and it'll tell you what pin 1 is. It's triode 1. Remember, this is a dual triode tube, so there's 2 tubes inside of one. The plate, so you're connecting it up to HV. So what you're really doing here is connecting between pin number 1, it tells you right here, pin 1, on the little set of blue plug connectors on the tube outlet panel, and you're going to connect that down with a jumper to HV1. And I happen to use a red wire because the HV1 is red. And then you just kind of follow down the list here and wire all that out, and you'll see what it looks like here when you're done. Okay, now we need to do this. So if you notice here, COM3, and it shows the serial number on my board, you need to click connect, and it'll come back and tell you your eTracer is connected. And I think the reason this exists is you could have multiple eTracers connected up to one PC. And at that point, you're talking to the eTracer. If you'll notice over here, it'll tell you your heater voltage and heater currents. Nothing right now because we haven't hooked up a tube and turned the heater on. But it does tell you the system voltage being fed to your motherboard. Remember earlier we had measured that around 28.9 or so. I guess with a load on it, it's a little less. And then this temperature is the actual temperature of the motherboard, not the tube filament. But we're going to go ahead and turn the heater on, and it recommends you kind of leave that on for about a minute to let the tube itself warm up. So I'll just be right back. Okay, we've let the tube warm up for 60 seconds now. And there's a couple different test modes you can do here. You can do a quick scan, which is pretty much, and you can see the parameters it uses here. It's pretty much a quick test of the tube within a certain operating set of parameters, very much like a kind of a Hickok 539 or a TV7 or a triplet 3444, whatever would do. So let's run that test at this point in time. If you click run now, you'll see the HV1 and HV2 lights are lit up on the tube tester. And now it says quick scan is complete. Okay, and you can see here the curve traces. It kind of tested this tube around the 250 volt operating range here. And then over here you get your quick scan results. And you can actually see here the reference is 1600. That's what a new 12AX7 and micro mode should read on either side. And this one measured 1472 and 1475. Which means that the tube is 92% good. Anything up in that 90% range is really, really well. I would consider this a strong tube that tests strong. I wouldn't consider it new. But the beauty of this tube is, look at it, 92.0, 92.2. It's fairly closely matched as it relates to its GM values. As well as, current-wise, it was 0.8. And 0.88. That's plate current on this tube. And then where you'll get a more definitive reading on this tube is if we decide to run a full scan. Now I'm going to click on this now at this point and run it. And I'm going to pause the video because it takes about a minute for this to actually run, and I'll be right back. Okay, the good news about this tube, it finished its curve tracing. And so what this tester does is it operates this tube at various points all along the kind of the operating parameters of this tube, and it plots it out. The good news is these curves are fairly closely matched. I mean, they're pretty darn on top of each other, which means it's a fairly well balanced tube on both sides. There's also a test here called corners, and what this does is it kind of tests your tube at the extreme limits of your tube. There's a lot of tubes that may, when you test them with a tube tester, test okay, but then you put them in an actual circuit and they don't perform quite as well. And it could be that they're not testing well on the kind of outer ranges. So we'll run this test real quick. And if you'll notice, it's a really quick test, and it came back, and what it did is it pushed this thing at 400 volts and 500 volts, and it passed on both of those. It kind of just gives you a pass-fail result here. There's also a combo test you can run that does all three of these first three together in a combo. There's a heater to cathode leakage test that you have to reconfigure some things to do that with, so it's not part of the combo. Just some basic parameter settings here, and then this is pretty cool. You have a load line that you can play around with to maybe determine what would be the right quiescent points and load line points if you were designing an amplifier around this tube type here. all that I'll leave for Chris to explain. He goes much more in depth in this than what I did. I just wanted to basically show you that, show you how to run a quick test, show you how to run a full scan and kind of the corners test, just to prove that what we built actually ended up working out well. Did have a problem once I first got it built. I was having problems with the heater not coming on the tube consistently. Sometimes it would, sometimes it wouldn't. Thought maybe it was the green wires that plug between the sockets, and turns out it was not that. Turns out some of my soldering skills on the other side, I had a broken solder joint basically. So I don't know if it happened along the way or when I first soldered it, but we fixed that and all is back to well. One thing I would love to recommend for Chris to implement, I would love to have a button right here as part of the quick scan results that would let you just click print, and then it would print out. Give you an example. On the Amplitrex tube tester, it had a feature like that, and you could print out to a Brother P-Touch printer, just a small little label printer, and you could just click print and it would print these results out, and then you could just slap them on the top of a tube box. So be great for just testing a bunch of tubes really fast, do the quick scans, label your boxes you're putting them up in, and you would know the results. Or if you're a tube seller, that would be a great feature. So I'm throwing you a hint, Chris. You can maybe you can incorporate that into a future release there. But all in all, everybody, you can see this tube tester is working well. It is it's an exciting device. Okay, I'm going to go ahead and wrap this series up. I hope you learned something. It was primarily focused to one, educate you a little bit about the eTracer tube tester, and two, to show you actually how to go in the process of building one of these physically, putting it all together, hooking up the software and getting it going. At this point, I will turn it over to the videos that Chris has made. He's done a really good job of showing you a lot of the features and tweaks and various things you can do with this software. And it seems like every time he comes out with a new update of software, he'll post a video on that Facebook page telling you about the new features. So, the things I'm excited about the most, one, it's a small little tube tester that it's smaller than a shoebox, and I can sit it here on my desk, and it doesn't take up, like the computerized Western Electric unit I've got. It takes up half of an entire workbench. This is a small little device I can just leave sitting here on my desk all the time. I can drop a tube into it. I can test it. I can get the quick results. If I want to do a more in-depth, full scan with curve trace, I can do that. And the unit seems to be extremely precise and accurate. Hopefully over time the list of tubes that can be tested with it will continue to grow as more people input new data and upload those. But all in all, for what I've spent on it, I couldn't be any happier right now. So I just say thanks to Chris and team, whoever helped him out with this. It's a wonderful device. I'm glad to have it as a part of our test bench here at Blue Glow Electronics. Thanks for watching, everybody, and stay tuned. We got some more videos coming this weekend.